Okay, PreCalculus, section 10.6, parametric equations. Now, you'll probably notice that the last section we did was 10.4, and this one is 10.6. Yep, that's intentional because I am not going over section 5 with you guys in an online classroom situation. It is quite complicated without being online, and it's not necessarily something that we've got to have. So, but this is parametric equations. Now, basically, what we're doing when we're doing parametric equations is this. We have three variables involved. In the past, we have done equations like this. Y equals 3x squared plus 2x plus 1, or sometimes we wrote it in function notation, Euler notation, as f of x equals 2 cosine of x. All right, these are functions where y is a function of x. Well, in parametric equations, we add an extra variable. That variable is called the parameter, and it's typically the variable t. Now, the reason that we use t is that one of the biggest applications of parametric equations is motion in two dimensions that we do a lot in physics. Okay, we do that a lot in physics. So parametric equations are such that both x and y are functions of some other variable, and that other variable is typically t. Okay, so a parametric equation, y is some function of x, of some function of t, and x is some function of t. So when we write our parametric equations, we typically write it in this form. X equals to some function of t, y equals to some function of t. Okay, now graphically, they look similar. However, there is some subtle differences. Now, if you're wondering if this can be done on your calculator, the answer to that is yes, it can. Okay, to do this on your calculator, after you turn your calculator on, what you will want to do is go to the Mode button, Mode, and scroll down. Where you see function, the one next to it is parametric. Okay, if you'll highlight that and then quit, you will now be in parametric equation form, and we'll get back to doing this on a calculator in a moment. Okay, now when we are writing equations of parametric equations in our examples, we will always be using t as the parameter, even though it can be any other variable. It's just t is most often used. All right, if you will look at example 1 on page 732, it's also this first example in your PowerPoint. It's asking you to sketch a graph of x equals t squared minus 4, y equals 1/2 t, and notice that it gives you this. Notice that it gives you that. That is very common in parametric equation form. T typically has a limit on what you start it with and what you end it with. Now, one of the differences between a parametric equation and a function is that with functions, our graphs tend to extend to infinity in both directions. For example, if I were to graph a parabola in function form, This would be a parabola in function form. Notice that typically when I do this, I put arrows at each end of my graph to indicate, right, that it's going to continue in that direction forever and that direction forever. That's the one difference between parametric, or that's a difference between parametric equations and function equations, is that a parametric equation will have a definite beginning point and an ending point. It will not have arrows at the end of it. Okay? Now let's show you how to graph these on your calculator. The PowerPoint shows you how to do it by hand, but there's no reason doing it by hand. You can do it using your calculator. Alright, so go to y equals. If you've already set it up in parametric form, you will notice that x1 and y1, notice that they're together. My first graph has x1 and my second graph has y1. Okay? My x1 is t squared minus 4. So I'm going to go to my variable button and I'm going to press it. I'm going to press my variable button. Now notice my variable button says x, comma t, comma theta, comma n. That means that if I'm in function notation, x is my independent variable. If I'm in parametric mode, t is my independent variable. If I'm in polar, theta, and if I'm in sequence, n. Alright, so since we were in parametric, my variable is going to be t. So I do t squared minus 4. That's my x. My y is 1/2 times t. Okay, now I need to set up my window. Now this tells me my t min is -2. My t max is 3. My t step, I just usually make it a fairly small number. 0.1 is reasonable. My x min, I'm going to make it about, I don't know. Let's make it -5 to 5, and then x scale is 1, y min is -5 to 5. Now you can change x max, x min, y max, y min to make sure you can just fit the graph on your screen. Then you press graph. Alright, and then we get that type of parabola right there. I'm going to make my x max a little bigger because I think it goes past 5. So go back to my window. I'm going to go back to x max. Go make that 6 and see if it goes past 6. It does not. It actually stops at 5. Okay? Now that's how you graph parametric equations in parametric mode. Now, what's interesting about this, if I were to ask you a question and I say, is this a function? Just by looking at the graph, you would tell me that no, this is not a function. But when you do it in parametric form, it is a function, because we now have 2 dependent variables and we only have 1 independent variable. So parametric equations are a way to take things that normally aren't functions and make them into functions by adding that extra variable. Okay, now notice this does have a beginning point and an ending point. Now typically when you graph these by hand, if you were asked to graph this by hand on a test or something, or in a college class, one thing that's important is this. Make sure you include your endpoints. Okay. Now the other thing that's important, and if you didn't do so, is it's important to indicate the direction that this graph goes. All right, so I'm going to go back and graph this. So let's watch it when it graphs. See, it started on the y-axis at 0, -1, right, and it went to the left. So when you're graphing that on a piece of paper, you need to indicate the direction that this is going by putting little arrows like this, indicating that that's the path it's going. Okay, that's not something that's taught in some books, but that is important. In your textbook, they do a good job of doing that. All right, any questions? Now, to convert a parametric equation to a rectangular equation, we do the following. And let's just go with this example that I have. If I were to solve one of these equations for t, it doesn't matter, I could solve this for t or I could solve this for t, I would get, in this case, t equals 2y, t equals 2y, and then substitute 2y in for t up here in my original, I get x equals 4 y squared minus 4. So x equals 4 y squared minus 1. We know that this is a sideways parabola, right? And so we can determine that that is indeed the correct type of graph. See how that works? So doing this is eliminating the variable to get a rectangular equation. This is graphing a parametric equation. Now, if you've got a rectangular equation, for example, y equals 4x minus 3, and you want to take a rectangular equation and you want to make it into a parametric equation, that is extremely simple. It's as easy as doing this. X equals, y equals. If you put x equals t, then y becomes 4t minus 3. You've got the parametric equations for that line just simply by doing that. That is not complicated. Now, what is complicated is when you get parametric equations involving trig functions. For example, x equals 3 cosine of t, y equals 4 cosine t. Now sometimes these are written instead of with t, theta, but it doesn't matter. You're still going to do this the same way. I need to change this to sine. Now whenever sine and cosine are involved, and typically it's going to be like this, sine and cosine, you have to remember the Pythagorean identity, cosine squared plus sine squared equals to 1. Alright, so I want to solve this for cosine. I want to solve this for sine. And then I want to put that in here. So I'm going to square this. I'm going to square this. And I get that. Now you should recognize this. This is an equation of an ellipse. So if this is an equation of an ellipse, this is an equation of an ellipse. Now if you want to graph this on your calculator, you will need to do it the following way. First of all, you need to make sure I'm going to clear out my equations here. I've got 3 cosine t. I got 4 sine t. I also need to make sure I'm in radian mode, because when I graph sine and cosine, I need to be in radians. Okay. Now I got to fix my window. Now whenever I'm involving sine and cosine, I need to change my t min and t max to 0 is min, 2 pi is my max. I don't have to change any of this unless I want to. Press graph. I should get an ellipse. Now you're saying that looks more like a circle. But if you'll notice that on x it goes through 3 and -3, but on y it goes through 4 and -4. That should not be coming as a surprise to you, because what's the square root of 9? Positive -3, so it should go through 3 and -3 on x. What's the square root of 16? Positive -4, so it's going through positive 4 on top, -4 on bottom. Even though it looks like a circle, it is not. Now you can make it look like an ellipse if you'll do the following. If you'll do a zoom square, it'll take care of that for you. It looks more like it's supposed to in that particular case. Okay, so that's what you have to do with this particular section of parametric equations. Call me if you need anything.